Hello developers, let's start developing. We're taking on day 3 of the Advent of Code 2025 and now we need to go to some escalator and fix it. We need to get some joltage into the escalator, otherwise it won't work. And the task is, each of these lines is a bank of some batteries and we need to find the ones that work best. We need to take exactly 2 batteries and we need to pick 2 of these. So we need to pick them. So the first one, if we pick 2 and 4, we're getting 24. And we pick 9 and 8, we're getting 98, and we need to maximize this. So the algorithm I'm thinking is kind of simple. From this part of the bank, which means everything but the last digit, pick the biggest number. And then once we pick the biggest number, from everything else, pick the biggest number. And that's about it. So let's get coding. First of all, the input is not gonna be a string array, it's gonna be a number matrix. Or since I like types, let's do it this way. We're gonna say that we're gonna have the type that models a bank of batteries. So this is not a bank like a bank, but it's just a bank of batteries. So we're not going to have a matrix of numbers because we're not treating it as a matrix. We're just going to have an array of banks. Let's change this thing anywhere, over here and over here, and I think we're golden. Now, the only problem is that we kind of need to return that from our processing. So we're going to read our input lines, and for each line, we're going to map it into, well, split it and then parse it something along this line, only we're not going to splitting it on a comma, we're splitting it on each character. So this will give us our banks. Let's actually see that. What is the problem? Because we're not actually returning that. We're gonna need to return not the lines but the banks. And the banks is here, it will be a matrix of numbers because it kinda is, but we're treating it as a bank array, which means that we can cook now. Let's see the input. Are we parsing it correctly? Seems like we are. So that's it for the input parsing, which means that we can get to the development part of this. How do we do that? Well, I will create a helper that's gonna be called process bank or get bank value, where we are giving it a bank and we're getting some result back. Yeah, Copilot decided that we need to get the sum. We don't, but it doesn't matter. So now we can just say let result be 0, and for each element of the banks we're just gonna bank value is get the value of the bank. We don't have any condition and we're just gonna add it to the result and return the result. Yeah, our input is also called input, not banks. So something along these lines. So I don't really care about the result while we're doing this. Yeah, let's use the non-debugged version. Just that the process is actually working. So the process is working and now we actually need to focus on how to get the value. So we're gonna say let the first one, since these are digits, the lowest possible digit is 0. So we're gonna set it at the minimum and we're gonna be off searching for the maximum. So I will try to get Copilot to run this code for me, to get this code for me, but I will just describe what I want. So I will say find the biggest digit that's not in the last place. And it already made some errors. We don't want to do that. So we're not gonna go from, we're gonna go from 0, but not over here. We're gonna go up to over here. So we're moving from the 0th element up to the penultimate element. The 1 here, the 1 here, the 7 here, and the 1 here. We can exit early because if we find a 9, for example, that's gonna be the biggest one anyway. And this is kinda useless. And we might also need the index of the first. Yeah, we're gonna put it at -1. So those are values before that. And now we will just say if, got it, what I needed now. So if the bank, and I'm gonna go with strictly bigger, because if we have multiple 9s, we actually want the first one. Because if there is a 9 here, for example, we want to take that, and we don't want to start from there. Yeah, because if we get this 9 as the first digit, the biggest value will be 99, but if we get this 9 as the first digit, the biggest value will be 91. And 99 is bigger than 91. So we're getting the first biggest value. And we're okay with that because numbers have that property. If the first value is the biggest one, doesn't really matter what the second value is, because 91 is way bigger than 89. So we're looking for the maximum. We're kind of greedy over here. We get that index, and then we have the first digit. So then we have the second digit. We don't really need the second index, and we're just gonna say find the biggest digit after the first. Yes, exactly that. And something along these lines, only we're not calculating the value. And I mentioned a few times that I don't like this I like index better because we're using it to index through an array. Seems to be okay, so let return first times seconds. Nope, return 10 times the first plus the second. That's how numbers work. And now we can say this to add a bit of debugging. So for that bank, the first is that many, the second is that many, the value is that much. Let's see. So the first one is 9, the second is 8, the value is 98, the value is 89, the value is 78, the value is 92. Looks correct. Yeah, and the total is 357, the total is 357. This seems relatively simple, which means that I'm kind of afraid of what will happen in the second part. Usually when the first part is too easy, the second part is a bit on the problematic side. Yeah, so let's remove the debugging thing. Let's run our code with the proper input and see that we get this many, 17,142. Let's check it. It's either correct or it's not, and it is. We're moving over to part 2, which means we need to do some more reading. So, the second part is a bit trickier. we need to turn on 12 batteries and get a 12-digit number. So we kinda need to do this thing that we did kinda sorta hard-coded for 2 digits, but we're gonna need to do it 12 times. Great. So the basic code for part 1 will be identical to the code for part 2. The only difference is that we're gonna create another method, bank value 2. Yeah, since we have exactly 2 parts, I'm quite fine with naming methods 1 and 2, otherwise this would be a huge red flag. So one way to do it is to have 12 pieces of code like this, and that would work. But I guess that's not really ideal. I mean, in this case, it is the 12 is kind of part of the specification, so we can do this 12 times over, because the algorithm will kind of stay the same. In this case, we have those 100 items, so it means that we need to find any number that is not in the biggest number that is not in the last 11, because if we pick one from here, we won't be able to pick 12. So most likely we get these 5 or something like that. How many are left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, in this case we're gonna pick the 5, and then the second number has to be after the 5 but before the last 10, after the 2 before the last 9, and so on and so forth. And we can have 12 blocks of code like that, and then smush them into a number. But do we want to do that? That is actually totally viable with this kind of approach when we're using Copilot, because it will generate those code for us like that. We won't need to make sure that we write it twice, but still it kinda irks me. So I'm gonna add another method. And I'm gonna tell it, give me the biggest number from this bank that's between start index and end index, because that's what we actually want to do. For the first condition is give me something that's between the zeroth index. Yeah, the end index is also a number. But it's not in the last 11. So this will be relatively simple. And we're greedy once more. So start from the start index, go up to the end index, not including it. I will rename this to end offset, because then instead we're gonna calculate the end index, because it's 12 from the end, 11 from the end, and I want the method to calculate that, not me. So when I say start from 0 and end offset should be 11, so index is less than 1 minus 12. Yeah, I think that we're gonna need to find it with 11. Let's go back to the smallish input so we can actually take a look at it. I'm not sure that we might have some off by 1 errors. Everybody hates working with indexes. So we're gonna need to do something like this. And here I might have I might need to run some tests. So I'm just gonna plug in a return 0 here. So give me the biggest number starting from index 0 and ending at index and offset. Yeah, should be 2 for the first part. So imagine that we again want to get just 2 numbers. That's enough. So it should give me 9, 9. Yeah, so let's see, we need to find this 7 now. Whether this should be 2 or 1, I'm not sure. One way to find out. So this returned the 4 instead of the 7, which means if we try it with the 1, we will get the 7. And then yeah, this will work. We can have this return not the biggest number, but the biggest and the indexed. So this is just gonna return a tuple of numbers. So instead of doing this, we just say index plus 1. And notice, yeah, in this case, we gonna need a 0. So let's, yeah, have that. Yeah, we don't care about the index of the second one. So this will look a bit better. Let's see if this actually solves the first part of the task. Seems to. Yeah, that's kinda okay. So let's go with this. So we can say now we have 11, now we have 10. This is still gonna be ugly. Yep. 8, 9, 10, 11, 12, and we don't really care about everything. And then we have this thing, which is totally ugly, but we did kind of generate it, and it proposed a console log as well. One way to find out. Let's see. 438889, is it correct? 8889 looks to be correct. Yeah, I don't like this hill of things because yeah, this can be looped through maybe, and this can also be a bit better, but for now, why don't we try it? Just let's remove the console log because we don't need that, and let's get our huge number. So result part 2 is 3121. Is that the correct value? 3121, 619, 619. Yeah. So we got some huge number, which I hope is enough digits that it doesn't. Yeah, let's see how many digits there is. If there are less than 16 digits, usually we're okay with JavaScript. And there are 15 of them. So, yeah, JavaScript is kind of okay until you get to 16, 17 digits, then it starts to get kind of approximate. So let's see if this is the correct value, and it is, because the code is kind of trivial, but is especially ugly. Yeah, we could change this with a for loop, and then we can make this something like that. But for now, I'm gonna leave it as is. I will try not to make it look better. There might be some more performant ways to do this, but I don't really think that's an issue since the execution times were relatively short, 1 milliseconds and 2 milliseconds. My only issue with this is that the code is totally ugly and doesn't really scale, because if we need to do 13 digits now, we might need to write some more code, or 14, some more code, or the first 20, and then it's way more code. But we were asked for 12 and we produced 12. It works. So that's about it. If you like the if you like the code that I've written, check yourself. But if you like this kind of content, like, subscribe, comment, and see you tomorrow, and keep developing. Wait. Don't go yet. I mean, this code is way too ugly to allow it to live. So what we're gonna do? We're gonna refactor this. So, of course, let's see how we can fix this. So we have our index set out for us. So basically we're going from 11 to 0. So let's do a for loop. Now it's gonna have an index. It's gonna go from 11 to 0, and we're gonna go the wrong way around. So we're gonna have our result. That's gonna be 0. And let's just, without saving this, let's see what the value that we need to find is. Actually, I think that we have this on over here. Let's see, day 3. Yeah, this is the result we're supposed to get. Because when we're refactoring, it's quite important to actually get the same result again. So, that is the result. So we need to now find the start index. Initially that's gonna be 0, which means that for each of these we're gonna need to get, yeah, something like this. We have the next biggest, we're getting the start index, and we're putting the index in. And for the next one, we're gonna need to set the start index to b index plus 1, because that's what we're doing, and we need to calculate the result. The result will simply be the previous value of the result times 10 plus the biggest. So whatever we get, we push it and add a value. Yeah, that is already set, so we can undo to that. And of course, we're gonna need to return the result. Let's try it once more with the small input. Three one two one. Yeah, that looks like the one that we actually had, 619. So yeah, let's run it on the big input. We got the value that we were supposed to get, I think. Let's check. So yeah, this works much better. I will just comment out this console log. Yeah, this looks so much better than what we had before. Yeah, I guess the lesson learned here is don't worry if you write some really ugly code. If you then go back in and refactor it to be better. Once again, mash those buttons and keep developing.